Hello everyone, welcome to video course AI for Healthcare Experts. New episode of this course where we talk about how machine learning and AI models see real patients. So because they don't see patient, they see only data, and their expertise come not from reality but from something that was recorded. And sometimes it's good because they can remember and they can know like millions of records, but sometimes there are some issues with this, and in this episode we will review what can go wrong and how to mitigate it. The main goal of this episode is to explain and describe potential problems with data when we train AI models, to first of all prepare everybody to manage expectations, what to expect from model and what not to expect, and to secondly, to if you go into build new model or you participate in some research project, so that will, I'm sure, will help you to build perfect reliable generalizable model. And last but not least, I think the most important, the goal of the episode to describe if you know how it works, you have more trust and you can use it more responsibly, more reliably, and more professionally to use models that you have in your own hospital or that will be someday introduced anyway, because anyway we will have them, I think, in any hospital in the world. So medical data, how AI sees patients. What is important? ML models, machine learning models, they see, usually they are trained based on some recorded results of analysis or records in electronic health record system. So AI input, it's always some structured representation of reality, and currently in 99.9% of the models, AI knows only part of the data. So for example, we work with AI decision support for mechanical lung ventilation, and our model knows only data from lung ventilator. So it doesn't know, for example, blood gas analysis. So this is significant limitation, and pretty the same for any other model. So if model classifies X-ray scans, so it doesn't know other analysis, at least at the moment. So it's the question of the future multimodal data that takes into account multiple sources of data, but at the moment it's not the case. So that's one of the things that we must take into account. The second important point, and here we will do some interaction. We have 4 measurements of blood pressure, and for example, we took it like in just repeated measurements, and it always was a little bit different. So what are the real value? Like first measurement because it was first, or last one because it's last. In reality, the right answer, actually we don't know, and actually doesn't matter. It's something in between. So we have some estimation of real blood pressure, and real data can be very noisy, and important that models that we train or that we use, that they were trained on real noisy data, because when it's ideal, some simulated world, when it is some noisy data removed on purpose, the model performance will be maybe nice on training dataset, but on real dataset it will be much worse. So that's pretty important, that good model should have noisy data, and it should know how in reality things happen. That sometimes it can be even no value at all for some parameter. Sometimes, like for example, in this case, it can be errors. So this patient obviously like very likely this patient doesn't have pneumonia because his other parameters are pretty well, and we don't know the reason why in electronic health record system this patient had labeled as a pneumonia. Like let's say no. Maybe it was reimbursement oriented coding. Maybe it was just copy from another patient. Maybe it's some outdated diagnosis. So maybe it's just a mistake. Maybe it can be millions of other reasons. And sometimes it can be no value. Sometimes it can be mistake. And it's also important that when we train model, we must understand that model will have all this information. So it trained also on wrong labels. And if actually model is good, it will label this patient as healthy, like no pneumonia. And in final metrics, it will be classified as false negative. So because in trained dataset it's labeled as pneumonia, and model doesn't agree with this. So and this is good. So good model cannot provide 100% sensitivity and specificity on trained dataset. So it always should have errors during training, because if it so I always very suspicious to models and to results that like show like 99.8 like or 98.9% for all the metrics like accuracy, specificity. We will talk about this next time, because it means that it's overfitted, and I have huge questions to like how it was validated, because and how it was labeled. Because in real world we never have this metric. So in real data, in real world, more noisy and has more mistakes than like 99.9%. That's also we need to take into account, and we need to be cautious to models that show that the accuracy like 99.9%. Second thing that we need to take into account, if we want to predict, for example, like sepsis or ARDS or pneumonia or like clinical deterioration, the question will be always, okay, but what is sepsis? And depending on definition or depending on country, the results will be different. So this is, for example, timeline for evolution of sepsis definition. So we see that it was constantly changing. And if we train, or if you have trained data, or you have to implement data that was trained on data from like 90s or before like 2010, very likely it will predict sepsis not as we define it now. And the same with ARDS, the same with everything. For example, if we predict like can we discharge patient from lung ventilator, depending on in which country we had labeled data, the results will be completely different, because procedures and protocols and markers for can we discharge patient or not and how we will do it completely different in different countries. So that's what we need to take into account when we want to implement model or when we want to build model. So in this case, models that rely on physiology, for example, models that classify ECG data and detect like arrhythmia or some atrial fibrillations, etc., they are more reliable because like they based on not on EHR data, they based on some well-defined patterns in time series data. So that's something that's a little bit easier to make interpretation. In other cases, try not to dive very deep into specific workflow in your hospital. If you're building AI for your like AI for healthcare, make it maybe broader and make it more flexible regarding what do you want to recommend, because in different hospitals in different countries, reaction on some events will be different. So that's something that is need to be taken into account, and this is some specific of medical AI, because definitions and things how we measure this are very different. And one more thing that we will talk about this more in episode about bias and drift, but one of the demonstration of also what happens when we have when we train model in one hospital and try to implement in another, but patient distribution and some processes and medical equipment little bit different. So there is a huge chance that it will perform worse because it was very fitted to our hospital. And to improve situation, we need to, for example, add hospital data from hospital B and retrain model. How to do it, it's another question, but assume we can do it right. And please notice how this line will change. So currently for hospital A, model draw this line to separate like healthy and unhealthy patients. And in this way, it's completely different, so significantly different line. Moreover, for hospital A, performance became worse, so accuracy became 79 compared to like 80 plus when the data was only for hospital A. But overall, average accuracy became better, and we can also say that model in the hospital C or D will perform better because its model more generalizable. So this is worse performance, not always bad, because sometimes it's still valuable, and models more generalizable. So that's also very important. Any AI should be tested on some external data, and please take into account when you build your model to check model performance on something that even you never seen. So it should be completely something different, or at least take into account and be aware that it cannot be used, for example, in some conditions that model was not tested before. But what is good, there are a lot of ways how to mitigate it, how to uptrain models, and it's the question of just some additional data. So usually it works very well. Overall, AI trained on data, AI trained on real world data that is not ideal, that's usually noisy, wrong, controversial, and good model still perform well even considering these errors in data. But we need to remember that potentially it can lead to some unexpected results. So that's what we need to double check before implementation. Subscribe on our video lectures, ask questions, please click like button, share, suggest your ideas for new videos, and provide another feedback. I'll be really appreciated.